welcome class. This is Form 3 Physics, and our topic today is work, power, and machines. Our topic today is work, power, and machines. Let us go through it together. Let us go through it together. The first one is work. What is work? Work is done when a force acts on a body and the body moves in the direction of the force. Work is done when a force acts on the body and the body moves in the direction of the force. Mathematically, we say work done is force times distance. Work done is force times distance, which is equal to W equals to F times D. W equals to F times D, where W is work, F is force, D is distance. The SI unit of work is always in joule or Newton meter. You can give the work as joule or Newton meter. Therefore, 1 Newton meter equals to 1 joule. 1 Newton meter equals to 1 joule. Example: a girl of mass 50 kg walks up a flight of 12 steps. If each step is 30 cm high, calculate the work done by the girl climbing the stairs. Calculate the work done by the girl climbing the stairs. Solution: work done is force times distance. So, force we get by converting mass into weight. What do? We multiply by 10. We multiply mass by 10 and we get 50 times 10, which is 500. So, force is 500. Distance, we convert 30 centimeter into meters. That is 0.3 meters. And there are 12 steps. So 12 steps times 0.3 meters. What do you get? 3.6. So work is force times distance. 500 times 3.6, and you get 1,800 joules. 1,800 joules. Example 2. A car traveling at a speed of 72 km per hour is uniformly retarded by an application of brakes and comes to rest after 8 seconds. If the car with its occupants has a mass of 1,250 kg, calculate the following: the braking force and the work done in bringing it to rest. The braking force and the work done in bringing it to rest. Solution: force is equal to MA. Force is equal to MA, where M is mass, A is acceleration. And how do you get acceleration? From first equation of linear motion. A equals to V minus U over T. So the car was brought to rest. It therefore means final velocity of the car is 0. But initial velocity, U, is 72 km per hour. How do you convert 72 km per hour into meters per second? We multiply by 5 over 18. And that gives us 20 meters per second. So we substitute for A. A is equal to V, which is 0, minus U, which is 20, over time is 8 seconds. And we get negative 2.5 meters per second. So negative simply means it is a retarding. So a negative acceleration is a retardation. It's just a retardation. So we write retardation is 2.5 meters per second. Therefore, braking force from our first formula, F is equal to MA. We take 1250 times 2.5. What do you get? 3,125 Newton. 3,125 Newton. Part B, work done. Work done is the change in kinetic energy or kinetic energy lost by the car. So recall the formula of kinetic energy: half mv squared minus half mu squared. V is 0 because this is the final velocity is 0. U is the initial velocity, which you got as 20 meters per second. So if you substitute there, mass is given as 1250. So substitute the figures in the equation and you get confirm negative 2.5 times 10 raised to power 5 joules. Negative 2.5 times 10 raised to power 5 joules. The next thing is power. What is power? Power is the time rate of doing work. Time rate of doing work, or the rate of energy conversion. Mathematically, power equals to work done over time. Power equals to work done over time. And the SI unit of power is always in watt. Is always in watt. Watt. And the symbol of watt is W. Or you can also give your answer in joules per second. You can also give your answer in joules per second. Let's get an example on how you can solve numerical problems involving power. A person weighing 500 Newton take 4 seconds. This person is weighing 500 Newton and it takes 4 seconds to climb upstairs to the height of 3 meters. So force is 500 Newton, time is 4 seconds, distance is 3 meters. What is the average power? You therefore say power equals to work over time. Power equals to work over time. But work we say is force times distance. Work is force times distance all over time. So we are given force there as 500, distance is 3 meters, and time is 4 seconds. And if you calculate, you get 375 watts. That is the power, 375 watts. The next subheading is machines. What is a machine? Generally, a machine is any device that enables work to be done more easily. A machine is any device that enables work to be done more easily. So in a machine, force is applied at one point, and the force we apply at one point generates another force at another point. In a machine, you apply force at one point, and this force generates another force at another point. So the force you apply is called the effort. The force you apply is called the effort, while the resisting force is called the load. The resisting force is called the load. So there are three quantities under machines which we need to discuss. Therefore, we discuss, and they are much important when you're doing numerical calculations under machines. The first one is MA, mechanical advantage. Mechanical advantage. Mechanical advantage is the ratio of the load to the effort. It is the ratio of the load to the effort. So L means load and E means effort. Remember, it is a ratio. So if it is a ratio, it has no units. It has no units. The next one is velocity ratio. It is the ratio of the distance moved by the effort. The ratio of distance moved by the effort over distance moved by the load. VR means velocity ratio, distance by the effort over distance moved by the load. And lastly is efficiency. How efficient is a machine? So efficiency is obtained by dividing work output over work input times 100. Work output over work input times 100, which is equals to mechanical advantage over velocity ratio times 100. There are two ways of expressing efficiency: mechanical advantage over velocity ratio times 100, or you can also use work output over work input times 100. Example: in a machine, the load moves 2 meters when effort moves 8 meters. The load moves 2 meters when effort moves 8 meters. If the effort of 20 Newton is used to raise the load of 60 Newton, what is the efficiency? What is the efficiency? Solution: we have said efficiency is MA over VR times 100. MA means mechanical advantage, VR means velocity ratio, which equals to MA is the load over effort. And the load we are given is 60 Newton, and effort is 20 Newton. What do you get? Divide 60 over 20, that is 3. Velocity ratio also is the distance moved by the effort over distance moved by the load. What do you get? Effort distance is given as 8 meters. Load distance is given as 2 meters. So you divide using your calculator, 8 over 2, that is 4. Therefore, efficiency is MA over VR. So just pick MA is 3, VR is 4 times 100, you get 75%. You get 75%. Let us now look at some examples of simple machine. Some examples of simple machine. The first one is levers. Levers are basically machines whose operation relies on the principle of moments. Recall the principle of moment in Form 2. We are told that sum of clockwise moment must equal to sum of anti-clockwise moment. Next one is pulleys. So this is a wheel with a groove rim used for lifting heavy loads to high levels. Heavy loads to high levels. There are 3 types of pulleys. We have single fixed pulley, single movable pulley, or a block and tackle system, which you can see in the diagram. The first one is single fixed pulley. We say it is fixed because the pulley is fixed on the beam or on the bar. You can see it there in part A. In part B, we say the pulley is single movable because the pulley can move to and fro. And last one, block and tackle system, which is a combination of 2 or 3 pulleys. So whenever you ask for the MA, mechanical advantage in pulleys, the formula remains the same. Just take load over effort. Load over effort. And also VR, velocity ratio, is number of pulleys over number of strings supporting the load. Number of pulleys over number of strings supporting the load. The next one is wheel and axle. Wheel and axle. It consists of a wheel. It consists of a wheel fixed. A wheel fixed on a rim. You can see it in the diagram there. The wheel, larger wheel fixed on the rim. And on the larger wheel, we have the effort. While on the smaller wheel, we have the load. On the larger wheel, there is effort. And on the smaller wheel, we have the load. So this is what we call wheel and axle. The bigger one is the wheel having the effort. And this smaller one is the load. Is the axle containing the load. So when you're asked to find the velocity ratio, you simply take capital radius R over small radius R. Capital R over small r. And mechanical advantage remain the same. There's no change in the formula for MA. It is just load over effort. Load over effort. Example. A wheel and axle is used to raise a load of 280 Newton. A wheel and axle is used to raise a load of 280 Newton by a force of 40 Newton applied to the rim of the wheel. If the radii of the wheel is 7 cm and axle is 5 cm, what is mechanical advantage, velocity ratio, and the efficiency? Solution. Mechanical advantage is load over effort. What is the load? Is given in the equation as 280 Newton. Effort is 40. So you divide 280 over 40, you get 7. Velocity ratio, we said is capital R over small r. Capital R over small r, which is 70 over 5, and you get 14. Therefore, efficiency is mechanical advantage over velocity ratio times 100, and that is 7 over 14 times 100, and you get 50%. 50%. Do more revision on the same, and please stay safe at home.